Myself, Vidya. My topic is causal, anti-causal, non-causal of a system in a Laplace transform. The Laplace transform is a linear operator that switches a function ht to hs, where hs is given by integration of minus infinity to infinity ht e to the power of minus st dt, where s is a complex. In a given LTI HT system, the HS is evaluated. The HS can be a unilateral or bilateral Laplace transform. Now, in this, we have to find out what is the region of convergence. When we plot S plane, that is j omega versus sigma, the values for a region of convergence should exist absolute values of integration of minus infinity to infinity ht e to the power of minus sigma t should lie less than infinity. Now, after understanding HS and also ROC, now we'll find out how to find out a causal, anti-causal, non-causal system for a given LTI system. Now, first example we'll take for a unilateral Laplace transform, that is HT is given by e to the power of minus AT ut. Now Hs is equal to integration of minus infinity to infinity e to the power of minus st ht dt. Now as given function is a positive function, now the limit changes from 0 to infinity. Now integrate. Now after substituting the limit, now Hs is equal to 1 over s plus a. Now, when you are substituting the limit for a given t, we can observe that the region of convergence will exist only for a greater than 0, that is for positive values. Now, ROC is real values of s greater than minus a. Now, plot the S plane, that is j omega versus sigma. Now you can see that minus a is a pole. Now ROC exists greater than minus a. So now these are the ROC in a S plane. Now we can observe that the ROC is associated with a system for a RHS plane, that is right of plane. So it is a causal system. Now as your j omega passes in a ROC plane, that's why it is a stable system. Now we will going to take a second example. Ht is equal to minus e to the power of minus at u of minus t. Now we can observe now as the u of minus t is a negative signal. So now when we substitute in a given in this formula, that the limit changes from minus infinity to 0. Now after integration, Hs is given by 1 over s plus a. Now when we substitute for your t, the limit minus infinity to 0, so now ROC will be converges for a negative values, that is less than 0. So ROC is real value of s less than minus a. Now when we plot j omega versus sigma in a S plane, that pole is minus a. Now ROC exists for less than minus a. So this is my ROC. Now in this, the ROC is associated with the system function for a LHS plane, that is left half of a plane. So it is a anti-causal system. Now HS does not include the j omega xs in a ROC plane, so it is an unstable system. In previous example, we observed for unilateral Laplace transform. Now we will take one example bilateral Laplace transform. That is, ht is equal to e to the power of minus 2t ut plus e to the power of 3t u of minus t. Now in this we'll observe whether the system is a causal, anti-causal, non-causal, and also stable or unstable. Now Hs is equal to minus infinity to infinity ht e to the power of minus st dt. As the given system contains both positive as well as negative signal, so the limit runs from minus infinity to infinity. After integration and substituting the your limit, Hs is equal to uh, uh, 1 over s plus 2 minus 1 over s minus 3. We can observe that the pole exists for minus 2 and 3. Now in this, when we substitute the limit for a positive side signal, the ROC exists for a greater than 0, that is your real value of a s is becomes greater than minus 2. Now in the negative side signal, the ROC exists for a less than 0, so that means the region of values will converge only for a negative values. So ROC is real value of a s less than 3. Now when we plot your S plane for a pole minus 2 and 3, now the intersection we have to take as a ROC. Now in this, as the system is associated with both causal and anti-causal, so it is a non-causal system. Now in this, Hs includes the j omega axis, so it is a j omega axis in a ROC in a S plane, so it is a stable system. In this previous we have understood how to find out a causal, anti-causal, non-causal, and also stable, unstable. Now the references are Signals and System by Nagur Kani and Signals and System by Opanem. Thank you.